From game development to high-frequency trading, thanks to QDC, the Quantitative Developer Certificate.
Hello! So, you came to something called Many Ways to Kill an Orc or a Hero because, let's be fair, they all have a chance. This is the plain slide where you see my email addresses, some of them at the very least, so if you want to write to me, this is what you should use. The slides will be made available very quickly, probably tonight, if you want to know more about what's in there, because there's many slides. This is kind of a John Lakoff style talk if you've met him, like lots of stuff. So we won't be able to go in depth on everyone, but all the code compiles and our winbox and such links everywhere if you want to play with the code. So when you came here, you probably read the abstract, I guess, and it started like this. Our game programmers, which I'm not. And game engines involve fights between heroes and their foes. And there's many ways for them to kill each other, which is a short way of expressing what's in there. So this is what this talk will explore, ways for them to hurt each other, I guess, but I'm non-violent. So you might be wondering, what the hell is this about, and why is this at CppCon? I get that. So yeah, you have orcs, of course. And sometimes you have heroes, and well, these things happen. And lots of eating in shoes, and there's bloodshed, and it's bad. So, but that's not what we're going to be talking about, as you can guess. Well, somewhat, but not really. So, as I said, we're going to look at many ways for them to hurt each other. This will work better if you ask questions live, so feel free to go to the microphone, interact, it's fine, stop me if need be. Criticize if you're not happy, that's totally fine. Okay, I did this summer at the high-frequency trading place. Lots of comeback. It was quite fun. Criticism and everything. Okay? So lots of code on the slides. Lots. I tried to highlight the important stuff in boldface on every slide. It all compiles, as I said, but we won't be able to read the stuff. Okay? So just pay attention to the boldface stuff. It's going to be easier for you and for me. Cool? So let's start with this. This is all boldface, the first slide. So we have a character there with a name, with a life, but the important thing is that a character can suffer. This is the way this thing has been built. They hurt. So far, so good? Okay, cool. And a hero is a kind of character that can hit an orc, which is what you will see if you look down, because that's what they do. You know, that's what we have heroes for. They can hit dragons too, but that's not the topic of this talk. And you have orcs that are characters that can hit heroes, because again, that's the topic. So far, so good? Fine, it makes sense. So this is the way they hit each other, but let's make it simple. So if they're stronger, they hit more. And if they're not as strong, they hit less. And that's pretty much what it looks like right now. Cool? Cool, awesome. So, and then there's a lot of violence. We roll the dice because they have an equal chance of sorts to hit each other. And there's a pain at some point. One of them is not alive anymore, and we can declare a winner. And the code compiles, that's fine. So, I'm sure you already have in your mind an idea of what's good or bad about what you just saw, even though it went quickly. Of course, there's a lot of violence. So you might, if you want to leave, I understand. But again, violence is not the point there. So I'm interested in the ways to implement this thing in which they hurt each other. So we'll look at many different approaches and look at design points along the way. We already made some choices. We can just write tons of code and make it work. It's not always the best way of writing a program. So as I said, we've already made some choices, but I went quickly, so it might not have shown in your eyes. So let's look at a few things. My hero there was a character, but note the way I did inheritance. I used private inheritance in this case. It's a deliberate choice I made. Okay? So what I did was, I made it so nobody knows a hero as a character apart from the hero itself. And I just deliberately exposed services from my character through the hero like that, those I cared for. Because I didn't want to expose that relationship, you know? Sometimes there's things you want to keep for yourself, I guess. And that's sometimes useful. Because even though you can assert, in this case, that the hero is a kind of character through traits, that's going to work. You cannot pass a hero by accident as a character to a function, because from the outside, you don't know that there's such a thing as a relationship between these two. So it kind of prevents slicing if you're worried about that kind of thing. Well, why not? Kind of makes sense. I don't know if you like it. Kind of makes sense. This is an oversimplified example, of course, because you might say, well, in real life, I want to benefit from the knowledge, but the hero is a character. And often, if you use public inheritance, it's because you want to describe that relationship. That's usually because in the base class somewhere, you have a virtual member function. So you care about the fact that you can use through a character indirection, be it a reference or a pointer, functions that will in the end call the member functions of the hero, the arc, or what have you. Something like this maybe. So saying each character is a name, but they might have different ways of expressing it. But of course, if you want to put a virtual member function, you probably care about a virtual destructor, like Herb was pointing out in this missing slide, missing piece of slide this morning. Otherwise, if you kill the character, you might not kill the arc or the hero properly in terms of memory management and finalization. So you could say like this: I want people to know that the hero is a character because he has a peculiar way of expressing himself or herself. And if I call name, I want to have the right name function. So you could have something like this, like the hero just says, me is, no, the hero just spells his name out, and the orc says, me is, with the name after that, because no orcs have smarter vocabulary, as everyone knows. So this could kind of make sense. Cool. But a hero still hits an orc, and the orc still hits a hero, which is reasonable, I think. And you can have been trying in your code to exploit that relationship. So as you can see, a hero is publicly a character, and an orc is publicly a character. So you're saying, well, characters will fight each other. It's going to be awesome. So you write this attack from a character to a character function. One hits the other, and at the end, you print the results using the names. And you're so proud, except that there's this oops comment there, which is a sign something went wrong. What went wrong? What's bad?
An orc can hit an orc, or a character can hit, or a hero can hit a hero.
Yeah, but the character cannot hit the character so far because we don't have a hit function in characters, so you're lost either way. So you're trying to write this thing now, saying a hero can attack an orc, or an orc can attack a hero. It's not even going to compile because at this stage of character, the way we wrote this thing, there's no hit function. And as my friend there said, you could even have orcs hit each other, which is not that unreasonable because I think they have these kind of habits in practice. So the print part works, but the attacking part doesn't work because at the level of abstraction where we were so far, characters are not necessarily violent. It comes later in the process. So that's bad. So the code does not compile because of the way I designed this thing. Okay, so there's no character hit function. If we can look at it again, we're trying to do from it's to, but they're characters and there's no hit function in characters. This is bad. Okay, well, so okay, there are solutions to that. Everyone knows there are solutions. You could just add the function to the character. Why not? I mean, if characters want to hit each other, who am I to stop them? This is what's written there. It would work in this simplified case. I mean, but then if you implement it the way we used to implement it, now you have the strength thing that was not in character in the original design. Okay, so that's a feature creep. Oh, that's bad. Okay. So currently we have more modifications to bring into your design, and well, feature creep is bad. So you can look at this thing. You're putting pressure on the character class. You're shoving stuff upwards in your class hierarchy, saying, I'm going to fix the problem by adding stuff. That will end up being a big class, which doesn't happen in real games. Okay? No games have classes that are too big, but should they have some, this might be the kind of process that led there eventually. You could add strength, but if you want to have a kind of pacifist character that doesn't hit, well, you could say, I'm going to put a strength of 0 and be done with it. This is starting to look bad. Okay, so if you're shoving stuff like that without thinking too much, saying I'm going to fix the problem, at some point, this technical depth thing that people keep talking about, you're getting there. In the first place, you could say, why is a character able to hit another character? Was that the original design? Does that make sense for everyone to be that violent? Like you have merchants or something? It's kind of weird. So recording line. So if you're shoving stuff like that, you need to step back, you need to think. So this is where we are. So far, so good? This is the solution. So by adding features, we're like fixing quote-unquote problems, but we're creating problems. And writing code, even for something simple like that, without thinking, is just perilous. You're going to end up in trouble. We have friends here learning C++ in high school. Don't do that. So what do you want? Well, you need a plan, as I said. So you want heroes to hit monsters, in particular orcs, because that's the deal. You want monsters to hit heroes, because otherwise it's unfair. It makes for a boring game. And to make it fun, since orcs are aggressive and they smell, you can like put armor on heroes that's going to give them an edge. So you have to think about the implementation now. Let's make sure that all characters have a name and life points, because it helps for the display and stuff like that. You can say, well, you have the same rules for being dead or alive. No life, you're dead. You have a way to play with the way the characters and orcs and stuff name themselves. Let's keep that. We like that. And you still have a number of questions to think about. Should they be able to heal and stuff like that? But we're not there. You have interface issues too. Some will want to hit others, and there are bellicose. Maybe the way that you damage characters will change from character to character because like they have tough hides or armor or something like that. Maybe the way you deal damage can vary because you could have fire and bites, weapons, whatever. So let's try something. Okay? So we're going to try design. So you have character there. Okay? So you have a name, a life. You can check if it's alive or dead. So you're very happy with that. So this looks like a reasonable thing for a character. So you're very happy at this point. Cool? So you continue thinking and say, okay, something in this damageable can suffer. But that happens. Okay. They might not be able to retaliate. So like you have a chair or something. Something that is bellicose can hit, which is kind of what they do. You don't want everyone to be inclined to violence. And so you have heroes, you have monsters. So monsters, they speak like this. And heroes, they can wear armor. That's the way you distinguish them in the street. And you have armors to protect yourself. And orcs are kinds of heroes. They smell and they're proud of it because they're not that bright. So you have something there. So does this look reasonable? It looks like a cool game, doesn't it? Yeah, so you bring that on. So you're saying, okay, cool. I'm going to use classical techniques, runtime polymorphism with virtual functions, inheritance, public stuff. A character is damageable because I can hurt it. A bellicose is damageable because otherwise you can hit and not be hit in return. It's just a bad game. Hero is a bellicose character and has an armor, composition instead of inheritance. That's cool. A monster is a bellicose character, of course. And an orc is a kind of monster. So you're saying, okay, I have something. This is going to be the best game. Except that you might have noticed that we might have gone too fast. Because if you look at your thing, it looks like this. Well, yeah, there's that thing there. Oh, okay, but that's where your thought was leading you. It looks so good on paper. Okay, so you're thinking about this. Did I really want to go there? Well, it seems to be my design, so let's try this thing. Okay. So a damageable is an interface. So it can suffer and it can die infinitely. So far, so good? Cool. We're not saying who's making the damageable suffer, of course. That's beyond the scope. There's a lot of stuff there, but character is a virtual public damageable because you have this diamond thing that everyone knows. Okay, so and then you look at it, and there's this suffer thing that's overriding there, because in the interface, it's you shall be able to suffer, and here it's how you shall suffer, well, you shall lose life. Okay, so there's a side effect to that thing that's not cool. I went fast because there's a lot of stuff, but there were context per functions in previous versions, and this one has less because virtual inheritance and context per. A bit because, again, it's some kind of damageable, but because of that diamond thing, I make it a bit more complex, but it can hit a damageable, so that kind of fits the original intent. Cool. All by reference because you can lower the life points and stuff. There's this armor thing that's also kind of an interface with two implementations as an example in this case, taken from popular games, I guess. And from my memory, plate armors are tougher than scale armors, but I might be mistaken. It's been a while since I played. So yeah, so this could be abstract. I made it return 0. That's a totally political choice. So you do what you feel is good. Okay? And then these are examples. So looking at this hero thing, it's a character and it's bellicose. So you get that diamond thing because of the virtual inheritance from the base classes. And when you go down, Suffer says, well, if you have an armor, let's apply the effect of the armor to the damage and maybe make it nicer for you. And if you don't, well, too bad. And way up, the boldface stuff is, well, there's a unique pointer to manage the lifetime of the armor because it's a pointer thing in this case. You can switch it. And well, you can equip and unequip an armor if you're so inclined. So that's our hero so far. Cool? Okay, fine. And then that monster thing, there's less stuff because there's no armor, but it can hit another damageable. It could be an orc in this case because they're that angry. And they have a name, but they have limited vocabulary, which is what we reflect in this slide. Cool? Normally, when you have an orc and the name is more than 3 letters long with more than 1 vowel, it's an imposter. So there's a smell thing. Smell is important to orcs. Okay, so when you have an important concept like that, you get it out of the class and you make a class of its own because it has its own rules. So a smell is between 0 and 1, probably closer to 1 because it smells really bad. And there's a validation process there. It could be context explorer because smell is like a key thing. Cool? Okay. It's totally not important for the talk. And so orcs are monsters that have a smell and ways to qualify the smell with adjectives. and their name is formatted to say, me erg, or erg me smell bad, something like that. Okay? That sounds like an orc. Cool. So this is what we have. So now I can make a bellicose something attack a damageable something, which is kind of cool. But they're in character. It's less vague. So they have intent. One can suffer and one can make one suffer. But the print result is still based on character stuff. So that's cool. It's awesome. And the fight is still the same. The only thing I changed was I put a smell value on the orc because otherwise they would have been angry at me and we don't want that to happen. Cool. That thing works. It works. You can actually try it. It works. It does the job. So we have well-known but intrusive techniques. You know? We try to avoid inheritance these days because it's for code management, the evolution of your stuff, it kind of gets in the way. But it's not illegal. You know, it's correct. It introduces coupling. So it's mostly for the life of our code and the way we will live ourselves with it with the time that goes on. That's a bother. And we do know alternatives these days that involve less coupling, so we'd not use them. So virtual hierarchies, we don't see all that often these days. It used to be a fad, I guess, but they make objects a bit bigger. Not everyone understands the rules for the common base class initialization. It's tricky a bit. When I explain it to students, sometimes they look at me weird because the grandchild initializes the grandparent. There's some weird things going on. And the construction, yeah, as I said, of the shared base class is complex. Context explorer does not fit in well with these pictures. Not very modern, but still. But it does work. I mean, we just made it work. You can play with the code and kill orcs and heroes at will. So there are even upsides, because with this, we have common base classes. So we can have a vector of bellicose and make them all attack victims. And it's going to work, because they have a common base class. You can have pointers to the base class and join them together for a party of blood. Okay, and you can try it if you want. But if you're saying, I'm a modern person, I'd like something less intrusive, because virtual inheritance, I read a book about that and I stopped wanting to do it. Okay, cool. So our first attempt used bellicose and damageable as like kind of abstractions of sorts. We had abstract base classes, things that other languages might name interfaces. But that did allow us to put damageable people together and bellicose people together, so it's not all that bad. But what if we don't need to group them together? Can we make it maybe a bit more lightweight in terms of coupling? Well, this character now has no base class. The boldface there, no base class. I could reintroduce context explorer in some places due to that. I got rid of that coupling. This is pretty much a character from the first try. The armor is the same, still an interface of some sort. A hero is a character, everyone knows it in this case, but I made the hit thing a template. Now, damageable in this case, it's like class T. It's anything, really. I didn't say that it's damageable, but it's my way of expressing my intent in a name more than in a type. So, but clearly from the code, you can see that other has to be able to suffer. Okay? So if I pass to this function something that cannot suffer, I will get those weird compilation errors that we all love. Although our compilers are getting better at this. I got actual reasonable diagnostics trying this. And I still got my suffer thing for my hero because I think my hero can suffer in this case if I want to make a good game. Although there's nothing saying it has to, but it does make sense. And I did the same thing for my monsters. They are characters too, and with the same pattern. They can damage something that can suffer, but I'm not adding anything to the type system, just saying, pass me anything, as long as I can call suffer and it's gonna work. Fine. My orc is some sort of monster with smell and everything, nothing much changed there. So, and I can still attack with a bellicose thing, a damageable thing, but in this example, there's no type information really, so I can really pass anything. Okay? But it's gonna work as long as the so-called bellicose thing can hit, and the so-called damageable thing can be hurt. If I don't make mistakes, this code works fine. And there's a lot less copying. But of course, what do you think? Good stuff? It's fast. Bon. I'm hearing problematic noises there. Okay, so there are upsides. So the function calls can be direct. In this case, it might be faster in practice. My objects are actually smaller because there isn't the overhead of the virtual member functions in some cases at least. The virtual base classes are gone. I have more space for const expert, but my code doesn't really use it, to be honest, in this case. But it could have been talk on that. This is what I'm doing. There's also downsides. Making a vector of damageable star, forget about it. It doesn't work because there's no such base class. It won't work. If I pass something weird to attack, I might get weird error messages, but of course that's QOI, quality of implementation. Maybe your compiler does give awesome messages for these, but the standard doesn't say anything about error messages, so you're on your own, but you might be lucky. And some people there could claim that my interface isn't clear because I'm not using like clear types in my stuff. I'm saying, pass me anything. I'm gonna call a hit and hope for the best.
Which I feel like you're heading us towards concepts.
I might go there at some point. But it's one of the ways I could go. But good function interfaces they're good for your code hygiene. I mean, people understand your intent when they're looking what you're doing. It's kind of a good thing, yeah. Okay, so let's try to make the intent clearer if you don't mind, because we're kind of hoping for people to understand our code if they're to manage that thing and maintain it at some point. So let's try to make the semantics explicit in intent from the source code, something like this. Okay, so I'm saying damageable is a concept. So type T is damageable if it can suffer from an int. Now that declaration valve there, if you're not familiar with it, it's a cool thing that says it's a function that doesn't exist. Well, you have the signature, but it's a semicolon, there's no body. You cannot call that thing. But you can use it at compile time with things like size of, align of, declaration type, in concepts. So I'm saying, if I add an int, this is what this thing means really. If I add an int, and I passed it to suffer for an object of type T, if that thing works, it's damageable. It's kind of cool. I don't even have to do it. I'm making it look like I can do it. And there's this weird bellicose test that you see just underneath. It's kind of weird if you look at it. This is because we have a problem in the language right now. I'll tell you about it in a slide. That's what I'm saying. In this function that I'm never calling, I think, suppose I have some x type that has a suffer of int function in there, and there's an small x object there. If I do d.it x for some type d, that thing is a bellicose. That's what I'm trying to say here. Okay? And then the concept bellicose underneath says, I require for some type t that bellicose test passes on a t. I find having to do that very annoying. Okay? You'll see why. And then attack goes from a bellicose to a damageable, but there the intent is ensconced in the source code. So it's much clearer than hoping for the best. Now, why is it that way? It's because the intuitive syntax doesn't work in C++ today. I tried it. So saying the damageable requires blah, blah, and bellicose requires that if I have some T that is bellicose, and something that is damageable, I can hit the damageable. That's not legal C++ and C++20. I checked with core. It seems like it would have worked with the original concepts, C++OX, that we didn't agree on in the end, that were more ambitious. But I think to find workarounds bugs me a bit. So it's something I'm planning to work on next year. This annoys me. But you know, it would have been cool, wouldn't it? But it doesn't work. At least it's a workaround. So the errors you get if you try that are something like, this is real errors. Placeholder type not allowed in that context. Or auto not allowed to require, it requires expression parameters. Blah. It makes me sad. Anyway, we'll work on that. I checked it, doesn't work. So we can, as I said, work around. You can craft something that does the same thing and use that in your concept definition. If you're clever, it's gonna work. It's just you shouldn't have to do that, in my opinion. Anyway, so the example is that. So this is kind of cool because your semantics are clearer, you're expressing your intent better, so your code should be easier to understand. And you probably will get better error messages, and contrary to function pointers and virtual memory functions, you're probably gonna get direct function calls there in most cases. It might make your code a bit faster. Good stuff. But we don't have a common base class. So there's no way, since damageable is a concept, not a class, to have a vector of damageable auto star. Forget it. There's no structural commonality. This wouldn't compile, okay? So if you want to group stuff for an assault, because orgs, they do that. Have you seen orgs? So if you want a group of attackers or victims in a container, the pointer to base class approach would work if there were a base class, but we don't have one anymore in this design because we have concepts instead. The concepts are cool. So we have this thing called variant. This is nice. So let's suppose we want to try this with variant, C++17 stuff, awesome. So there's a lot of stuff there, okay? But pay attention to the fact that we have examples of damageable stuff up there. Furniture satisfies damageable, it can suffer. If you don't believe me, try it in kids. Or cats. A bystander is a character, why not? Well, so that's okay. A bystander is a character, it just doesn't fight, it just suffers. And attack goes from one bellicose to many damageables. So it's template damageable ... .ps, which means I don't know what they are. They can all be different types, but they have to be damageable. And then I can visit and hit them all. This is totally cool. The make victims down there, I'm using a factory function to take a number of objects of different types and making a variant of that thing, saying I want these things. I tried making it with a deduction guide, but it didn't work for me. I've been told that, the factory function is easy to write, but I've been told, and that's true, that it's important for that make victim code to work, since it's making a variant of the types, that all the types are different. This code doesn't ensure it, but if you want to do it, like the code is there. Have fun, okay? It's doable. So let's keep things simple. Let's suppose user code doesn't do it. Cool? Just 4 pages of code. Okay, so there's this make victims thing there where I have an orc, because we can hit an orc, and it happens to have a furniture and a bystander there, because in a fight, things happen. And we have a hero that attacks all of those victims after that, including an orc, because we're on theme, aren't we? This is cool? Okay, cool. So we have a vector, a variant of damageable objects, and we can make grouped attacks without using virtual memory functions. The code looks kind of cool. Yeah, you don't lack, when you look at this, you don't really miss the common base class. It works fine. Code is nice. It compiles. Yeah. So you're saying, okay, code. We're doing math. We have a math teacher there. We want numbers. Well, it's better to measure those things because you need to have a goal. So when you're doing a design, you might want your code to be readable, you might make it teachable, who knows? You want to make it cohesive with the rest of the code base because you're bringing people to work with you and they won't understand anything otherwise. And that involves money, doesn't it? And for this case, I'm going to suppose, because it measures better than other stuff, that I'm concerned about size and speed. Okay? Closer to me. For those who were in my optimization class last weekend, you might get it. So I'm going to use size of and line of to see how much space they occupy and how they are organized in memory. And when I measure speed, I'm going to use this function. Those who have that class with me, you know what this is. I'm reading the clock before calling a function, reading it after calling the function. In the meantime, I call the function with perfect forwarding to make sure the arguments are passed the right way. It needs to be a non-void function because I'm taking the return type. And I'm returning a pair with the result. And the elapsed time, because compilers are very clever. And if you have no impact to calling a function, the function will be gone. So and you won't measure much. So if you're using that virtual base class thing in the beginning, oh no, the very first one, I think. So checking the size of character, hero, monster, blah, 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 with what we used to have. It gave me this with the compiler I use, but of course, all those numbers, you have to check from compiler to compiler, setting to setting, there might be changes. But this is what I got, you see? Based on this. So character had a string in there. The string on that machine, I think, was 32 bytes. 32 size of was 32, something like that. There was live there. So you had issues of alignment. So size of string was 32, alignment of string was 8 because there's pointers in there, 64-bit machines. And you're paying for padding probably in this case, and there's a pointer to the VTBL at the beginning. This is not documented stuff. The standard doesn't mandate an implementation, but that's what happens in practice. So this is the sizes that we get. Okay? And for hero, monster, arc, you might see that hero and arc are a bit bigger. It's because arc has smell and hero has an armor pointer, so that's pretty much what you get with this. Okay? So this is what you get. Size of character is 48. There's a number of things there. We're getting a setting 2 because there's a virtual base class overhead that makes our code a bit bigger. A bit of a bother. And size of monster is a bit less because there's no armor pointer in there. But with arc, you had the smell. So there. And if you run this thing and you make sure that you let your things hit each other for a long while, so attack, 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 attack. And I'm letting them hit each other even if they're dead. In this case, it's just lots of hitting. I end up with lots of attack. It's like 1 million victims 1,000 times. And it says 500 or so microseconds. Let's put it aside. Okay, so this is what I get with the traditional approach. It's just measurements. You need a baseline. And if you go with the variant approach, so you remove the virtual base class and stuff like that, get the numbers. Character is 48, but you might notice numbers a bit smaller in this case because the overhead of the virtual base class is gone, things like that. So your layout changes things a bit. So on this compiler, size of string is 32, size the alignment is 8. We still have padding. There's still a virtual member function for the name, so you're still paying for the VTBL. And this is interesting. It's very clever. Size of character is 48. Pay attention. You add size of int and size of void. So you have a 4 and a 16. And padding, so you have 64, but the compiler is very clever. And it finds a way to remove some padding between the base and the derived class in this case to crunch it a bit. They only do that with virtual member functions, though I don't know why they do that, how they do that, but I find that very clever.
That's actually compiler-dependent behavior.
Absolutely. Totally. That's why I'm saying this compiler is very clever. I didn't expect it. That's totally compiler-dependent. That's kind of cool. They can manage to make it. So yeah, they're hitting each other and everything, and I'm running numbers, and yeah, you might notice that I was in the 500s, and now I'm in the 300s. So you can see the difference in the way the functions are being called in this case. So there is an impact, so it does make a difference, okay? With the variant-based approach, there's a gain speed, a gain size, there's a gain speed too, so there's something cool about that. But doesn't mean it's always good. You have to be careful. There's reasons for everything. C++ is a wide array of tools for many kinds of programs. So I'm not saying use one, not use the other. That's what I'm saying. I'm just saying you have choices, and it's something that's worth measuring. So making informed decisions can lead you to make decisions that make sense to you. So there are other things to check. The compile times. If you have a non-finite set of derived classes, maybe you better stick with polymorphism in the classical sense because it's easier to add stuff without recompiling all the time. There's reasons for everything. Okay, so you're saying this thing likes dot, I guess? I can hear you. So let's see. So 1 euro, many orcs, or many euros fighting 1 orc are possibilities, but if there's many euros, many orcs, you're saying. That's what you're thinking. A big army of stuff, okay, cool. So rules are simple. A team of heroes against a team of monsters. It's not just everyone, it's everyone. The good ones and the bad ones are fighting against each other. And the first team with no one left alive loses, which is, well, I'm sorry, but that's how it goes. Okay, so 2 different ways. Again, I'm going to try to make it quick. One on traditional inheritance virtual number functions, one with concept invariants. They are not mutually exclusive. You can mix the two, okay? This is not a go one way, go the other again, just to see how it goes. So, different code, same intent. Damageable can suffer. Good point. Bellicose is damageable because we're honest people with life. And they can be alive or dead. I'm hoping that my definitions work. Life greater than 0, you're alive. Cool. And you can hit someone. That's damageable. So now, it's more elaborate because you want special effects and everything. So I have a weapon, but I put 3 sorts of weapons, hoping it works for you all. Then they differ because they make different sounds. So like a sword does zing, an axe does thunk, and a bow does boom. That's what I'm being told. I made research. Cool. Do you like the way the switch statement is written? With the using enum inside, I love it. So the using enum is scoped within the switch statement, it doesn't leak outside. It's a trick I picked from Jonathan Mueller a few years back. And of course, you have wizards. Wizards cast spells. So there's whoosh for fireballs and psst for lightnings. Cool? That sounds like a game to you? Cool. And spells make more damage in this case. Okay, so this is the way it works. And I have this initialize thing. I want the game to be fun, so I'm going to randomize the life at the beginning to make sure that you don't always know who's going to win. That cool? And this is not a really good way of getting an initial life because I'm reconstructing the random number generator and the distribution on every call. But, you know, it's an example. So this is probably the worst slide of them all, but it's going to work. So my hero is bellicose. It can hit a monster. Just a monster. You see that? Not anyone. Monsters. And my monster is bellicose and can hit a hero. Now, if we go back to bellicose. There. Notice that hit IMPL there is protected. You see that? So that means the derived classes can write this thing, but there's no hit at this level. You see that? Okay, that's the limit. So you can't use a bellicose the way the code is written right now and call hit on it. It's not going to work. Okay? You need a hero or a monster to hit something. But the way it's done will go through the IMPL thing. So if you look in this code at hit of an hero in class monster, it calls hit IMPL. And the same thing goes with hero content hit monster. I'm just restricting the types I can address. Cool? Cool. So this slide is very, very small, but it's the hit IMPL thing. So let's just say that wizards cast spells and heroes hit with weapons. And orcs and monsters, they do damage too. Okay? So be careful. Conflict begins. If you don't like violence, now is the time to close your eyes. Okay? Ready? Cool. So they're all dead if they're all dead. Is that okay? Fine? Cool. And this is the pointer-based thing, so that's why you see the little stars there. So hitting from some T to some U is calling hit, just to make the code simple. Cool? Make sense? Okay. And when I pick one to fight, because in my first iteration, I've been told that I let the dead ones fight because I wasn't even careful enough, so this one is careful. Look. When you want to pick one to hit or attack, while I'm splitting with partition the set of the vectors that I have there to put the alive at the beginning and the non-alive ones at the end, and I'm picking at random from those who are still alive. Okay, so the dead ones, they remain dead. That cool? Make sense? Cool. correct find. It's important to find the word the proper way. And this is my construction stuff, so I'm putting heroes in the heroes and putting monsters in the monsters. So there's Urg, who's an orc, and the Minotaur is called Timmy. I asked my wife, and she said that's the way Minotaurs call themselves. And the wizard is called Steve. Okay? It's an homage to Steve Jackson, I guess. So while there's still one of the groups that's not all dead, or both groups are not all dead, I roll the dice, or use a penny, I pick an attacker, I pick a foe, and havoc ensues. At the end, I'm saying who won, not the characters left, just which team won. Okay? Cool? Nice code, key code. So not too bad. But the code that constrained who can attack whom was kind of tricky. My base class had a protected virtual function, and my derived classes had public functions that called the protected virtual function from the base class to do the real job. So my constraint was based that way. It's not something I'm sure I would like to explain to newcomers in my company. It's a weird trick. Oh, it works. Okay. So if we go the concept invariance way, one way we could do this is like I said, this. So a damageable can suffer from an integer. We knew that. We've seen that before. This is the way damage works. A bellicose, in this case, it's a damageable object. So I put requires damageability. Again, I would have liked to say template damageable T concept bellicose, but I can't with the concept that we have today. They're still cool. I still love them, but I think I like love a bit there. And the way I express that I can hit something damageable is the thing that you see just below. I don't know if you like it. I like this sort of stuff, but not everyone does. If we read it, I have some type T, B object. I'm saying I can call hit on that thing with whatever the lambda returns in there. And that lambda says, well, I take whatever as argument. I take no argument, but I'm, so if internally I have a function signature f that would eventually return something that is damageable, and I return that, so that thing would be a damageable, but if I can hit that, I'm okay. There's no code there, it's just code signatures. So if you don't like that, just let's move aside. So there's still this cool thing. So heroes fight with weapons, I guess. Wizards cast spells, this doesn't change. We're still picking life at random, which is not the best slide, as I said. Lots of work there, but again, it's saying a warrior hits with weapons. It's a hero, but it's not shown in the slide because I don't need that coupling right now. If I wanted to constrain my hit there, because saying hit some type T, I'm just saying hit some kind of monster because I don't have a monster base class in this version, but you can make it work. If you do it like this with a list of possible monsters and possible heroes, or you can do it like this with a trait. Or you can do it like this with tags, but not the point of the class. If you want to play with it, do it. The thing is, my warrior can hit something, is going to be a monster, and my wizard can cast spells on something. Same goes with the orcs, the minotaurs, same thing. Okay, so ready? Close your eyes if need be. Ready to go? Okay, so I didn't have an alive and a dead function in those slides. If you look at them, I didn't write them. So, but I'm inferring alive and dead from some type T based on their life. So I'm saying if you have some type T, and I require that type T exposes a life member function that returns something that's an integral. So it's not a concept of being alive, it's something else. Well, alive will return true if life is more than 0, and dead will return true if it's not alive. Requires, it's the way to do this, really. Okay? So if you're saying twice requires, you monster, no, monster is in the slide, I'm a nice person. This is just the way we write those things. So the first requires says, I'm going to tell you what I need, and the requires clause that follows is the way we express the requirements. If we don't want to use a named concept, in this case, it's too small to be deserving of a name. So I have my variant there. I don't have a base class. So a hero is, in this case, a warrior or a wizard, and a monster is, in this case, either an orc or a minotaur. That's the way I wrote this thing. So they're all dead if they're all dead, but that's not done through a loop in the traditional sense calling functions, I'm visiting them. So I'm visiting them, each of them, checking if they're dead, calling the actual life function of the type I'm referring to. And when I'm attacking from an A to a B, well, I'm visiting both and calling the proper function of A with the proper argument B and actually hitting the thing. Visitors are cool for variant because you can pass them many arguments. It finds the right types for everyone instead of writing nested switch statements, which are so unpleasant. And it's type safe, so we love it. Ready? So fight begins. I'm picking one, the same way I used to do it, picking one of the live ones by partitioning the live ones at first, the dead ones at last, and picking one of them at random. Cool. Now I have monsters. I'm putting together things that are unrelated, but I have my variant thing. So a monster is either an orc or a minotaur. Go there, fine. And the fight begins while they're not all dead, they're attacking. Notice it's the same client code as in the previous version. The details are abstracted away in the way the types are constructed, which is so cool. And you can play with it. So same code syntactically, not semantically in both cases. Once the containers have been constructed, because there's that pointer thing there. And some of the auxiliary functions are different. I'm visiting in one case, calling member functions directly or indirectly with like arrows and stuff in the other case. It's cool when code looks the same in both implementations. It means you're doing something cohesive. Whew, lots of death and blood, isn't it? Okay, so what do we make of this? I know you're tired. There's so much violence, like watching a horror movie for hours, but it's been 50 minutes. What's the point? So we played with various ways of doing things that look the same. These are issues. It's nowhere near being exhaustive. Some of the things are compiler dependent, but it was just to explore. Well, it's fun to play with code. I like it. I had fun making this. One of the reasons was to show that we have a very cool language. I mean, we can do these things very efficiently in many different ways. And there's still some things that need work, I think, which I noticed working along this. And this surprised me. For me to go back to core where I normally sit, say, how the hell does that not work? Well, you know. So we have different costs depending on the approaches we take. It's not good or bad. It's a matter of trade-offs and what you're willing to play with. Sometimes it's that simple as you're hiring many people every year, and the newer stuff, if you use it too much, you won't be able to hire them, or you're going to have to train them for a longer period of time. It's not reasonable. That's a valid reason to make choices. In some cases, the limits add workarounds. So I showed a few if you want to play with them. That's kind of cool. I'm sure there's other ways of doing that. We could have gone further. We could have had a program where we do fight hero monster, fight monster hero, with many types of each, with algorithms that depend on what type we have. When you have polymorphism with two types like that and virtual functions, you write a lot of code. This is the same case as we used to have with collisions of different kinds of volumes. It's very much involved. Just for a very skeletal use case of 3 volumes, it's about 100 lines of code and you're doing almost nothing. It's unpleasant. Mr. Alexandrescu has a whole chapter on this kind of thing in his old book that was mentioned in the keynote this morning. It's not fun to write. So if we just want to print messages on screen, you can. I didn't put the code in the slide, there's much already, but I put implementations with variants and virtual functions. This is kind of cool to look at if you want to look at it, because it really shows different ways of thinking. And this thing, having many classes and functions that depend on 2 types or more, it's not a C++ issue, it's an object-oriented code issue. The same code, the same problems we'll see in Java, C#, and so on and so forth. Some languages do it better, but... So, what do we make of all this? Well, thinking before we code is a good thing. Because sometimes fixing by creating bugs, it's counterproductive. We have many problems, so we have many tools. There are problems that are better fixed with functions. There are problems that are better fixed with traditional stuff. There are problems we solve more nicely with contemporary stuff. But we're lucky, because we have C++. There's no single right way. I mean, this is the language that opens up so many paradigms to us and lets us think. It's a rich and complicated world, so it's cool to have all those tools. So we can have fun. So let's do some. Hope you had fun. Sorry for all the bloodshed. Any questions? Threats? Comments? Complaints? Did that make sense? No? Okay. Well, if you have questions, feel free. Come to the microphone though, or complaints, as I said, is fine. Otherwise you're free, that's okay.